part 2, section 6, absolute value. So in the first part we did absolute value when we had equalities. And let's just quickly get some review of that. So we'll recall absolute value when we have something like this. So we make sure the absolute value is alone. Then what do we do?
You set it equal to two different possibilities, -6 and 6.
And we want to make sure we get that negative case on the left, mainly because of what we're going to do today. And then we add the 8. We solve that one. And we'll add the 8. We'll solve this one. And it's 4. It's one of those.
So it shows come off as a positive?
Not always, but it did in this case.
When you were saying about coming out as a positive is the other side, the other side of the equation, 6, for example, can't be -6. It's not absolute value of x minus 8 equals -6 because
You just split it into two things. This whole thing could be +6 or this whole thing could be -6. So -6 and 6. We just changed that sign twice. Alright, and then we had some more difficult ones where we might have something like this. But we do the same concept. We get the absolute value thing alone. And then we change the signs. So we have the negative case this, so I change all those signs. Or we have the positive case. So in order to remove this absolute value, I need to account for two different things. And then we solve these. So I'd add my 3x. I'd add my 5. And I'd divide by 5. Do the same thing here, except I'll subtract the 2x first, so I get x. I'll subtract the 1. And now, before I finalize this answer, I want to make sure I don't have anything I need to reject. I can't end up with a negative here. So if I put in, this is almost 1, this is okay. 3 times 1 is 3 plus 1 is 4. That's okay. -6. -18 plus 1, that's going to give me -17. I need to reject this one. That one does not. So boom, that one's not. Any questions on this? Because this is what we did yesterday. We just need to make sure that we're okay conceptually with what we were doing with absolute value equalities.
I have one question.
Okay, so this is a question on which one?
I don't know. 29. Same.
You guys went too far. You're on part 2, which is what we're doing today.
Well, yeah, I looked ahead and.
Okay, well let's go through the notes that go with that, and then we'll deal with
I
that.
need 23 also. Is that also too far?
Okay, 23. No, let's do that. Okay, so 3. I'm going to use x instead of a w, just because it'll come out better up here. All right, so the first step is to get the absolute value alone. So what should I do first?
plus 1. Yeah, 5.
And then?
Divide by 2.
And then? Split into two cases, right? 4x minus 1 could equal what? Or 4x minus 1 could equal +5. And then I solve both of these. So I add the 1. Divide by 4. Add the 1. divided by 4. I get 6/4. I need to reduce. Always reduce your fractions. That's 3/2. So I get x equals 3/2 or 1.
-1.
Yes, -1. Because of negative divided positive. So this is the solution to that. 4. Okay, let's then start on what we need to know today. Yes, real quick.
No way the answer can be -5 plus I. Then you have to distribute this negative, which makes that negative, and 3 is bigger than 2, so it's going to be negative. And the book says -5 plus I.
Okay, so that's -1, right?
Yeah, but I thought you have to like distribute and then just do like.
Well, you did distribute, and what's this equal?
Huh?
What's I cubed equal?
-5.
Okay, so we're going to replace that with -I, but then that's going to make it positive. And then I squared is -1. So you jumped too quickly to this step. Replace that one and replace that one.
What?
Anyways, okay, so absolute value, inequalities. Absolute value, inequalities. All right, so let's say I want the absolute value of x to be greater than 2. We'll start with a simple thing here. And let's go to a number line to see what this is meaning. Here's the thinking. I want the absolute value. I want all the numbers whose absolute value is bigger than 2. That's what I'm saying there. I want all the numbers whose absolute value is bigger than 2. All right, so let's use the number line. Is the absolute value of 0 bigger than 2? Yes or no? No. Is the absolute value of 1 bigger than 2? No. Is the absolute value of 2 bigger than 2? No, but it's really close, right? So I'll put a circle here. Is the absolute value of 3 bigger than 2? And anything there further also, right? So going this way. Now let's go the other way. Is the absolute value of -1 bigger than 2? No. Is the absolute value of -2 bigger than 2? Yes or no? Is the absolute value of -2 bigger than 2? That's what I'm asking. No, but it's close, right? So I'll put a circle here. Is the absolute value of -3 bigger than 2? Yes. And then all going that way. Let's try one more. Absolute value of x bigger than 1. Number line. 0, 1, 2, 3, -1, -2, -3. Okay, so I want all the numbers whose absolute value is bigger than 1. That means when I take the absolute value, I get something bigger than 1. You with me? Okay, so is the absolute value of 0 bigger than 1? How about a half? What if I went halfway? No. How about 1? It's close. That's why I put that circle there. Because I could have it equal. There's somewhere we're equal. Absolute value 2?
Yes.
Absolute value 3? And so on and so forth. How about -1/2?
Yes.
How about -1?
Close.
Close. -2?
Yes.
-3? And so on and so forth. You see what's happening? I get this, it looks like a disjunction, doesn't it? So, I have two possibilities. I have x could be less than -2 in this one, or x could be bigger than 2. And on this one, I could have x is less than negative 1, or x is bigger than positive 1.
So they're always facing away from each other.
If it's greater than. So for greater than, or greater than equal to, we're going to use an or case, where they're going opposite ways. Okay?
And does that mean with less than, it would be going towards each other, so would you have an and?
Yep. We'll get to that in a minute. Let's do some examples with the or.
We look at the notes or on the board.
In our notes, because they're going to be more complicated than this. So let's say I have 3 times the absolute value of 2x plus 1 is greater than or equal to 9. So my steps are basically the same as for equalities, but I am going to have to account for this greater than thing. So I'm going to divide by 3 first. See, I divided all of that by 3. Now, I am going to quickly, right here, sketch my situation. And I don't need to be very detailed, just enough that I know what's going on. I want the absolute value of numbers that are bigger than 3, which we've just practiced, right? This time I fill in the circle because I can include it because it's equal. So I have this case. I'm going to use this to fill in. So I have to split this into 2 cases. 2x plus 1. But look, I'm going to use this for my symbol. Look, I'm going to use this for my symbol, less than or equal to, because that's less than or equal to negative 3, or 2x plus 1, because I split it into 2 cases, right? Greater than. I use this to fill in my other case. And now, just like equalities, I continue. I use this quick little sketch of a graph to help me fill this in. Now I subtract my 1, and I divide my 2. Remember, if I divide or multiply by a negative, I flip this. I didn't, but just remember that. Subtract my 1, divide by 2, and now I have my answer. Okay? Now, without sketching this, here's another explanation, another way to think of it, if this helps you. Remember, when we multiply or divide by a negative, what do we do with this symbol? We switch it. So let's start at this step, and let's do it without the graph, just so that you can see what's happening. So, I need to switch it to 2 values, right? A negative 3 or a positive 3. So 2x plus 1, I essentially have multiplied this by a negative 1. When I do that, I switch the direction. And then when I do the other one, I don't multiply that by a negative 1. So this stays the same direction, and I end up with the same thing as I do down here, and I end up with the same answer that I've already gotten, with the same work. Okay, so there's 2 reasons why we end up with this OR case. Because of this graph, thinking about why, absolute value number is bigger than 3, or when I switch this sign, that should be a negative 3. I multiply by a negative, which means I need to switch this to the other way. So that's the disjunction OR case. We have another case. We're still ready. Be good. We're good. Okay. So, let's start easy. Let's say less than 3. And let's use a number line to help us. 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. And this time, I want numbers whose absolute value is less than 3. Numbers whose absolute value is less than 3. So, is the absolute value of 0 less than 3? Yeah, so I'm good right there, right? And same with 1, same with 2. 3 is close, absolute value of 3 is close, so I'll open circle. What about absolute value of 4? No. And then absolute value of 1, that works. And absolute value of negative 2, that's good. And negative 3, well, that's close. All right? And then absolute value of negative 4, is that less than 3? No?
And positive 3 is not negative 3.
Right. Well, absolute value of negative 3 is 3, so it's close. And absolute value of positive 3 is 3, which is close. So all of these, right? That looks an awfully like a conjunction. And. You see what I mean? So how do we do this? Well, it's between that. Negative 3 is less than x is less than 3. It's sandwiched. See? Sandwich. And we're done. So what if I had something more complicated? What if I had absolute value of 2x plus 3 is less than or equal to, let's say, 5. So I'll sketch my number line. Now this time I'm going to do a sketch. I'm not going to get all the numbers there because it takes forever. See, I want all the absolute values that are less than 5. So does negative 10 work? Well, the absolute value of negative 10 is not less than 5. Absolute value of negative 5 is 5, so that one works. And now I have this equal to, so I can include it. Absolute value of 0, that's less than 5. And absolute value of 5, that works. Absolute value of 10 is not less than 5, so that does not work. So I have all the numbers right here between. See what I mean? So I just drop that down, and I'm like, all right, so this stuff right here must be between these two things. So I have negative 5 is less than or equal to 2x plus 3, which is less than or equal to 5. I have a sandwich case. Subtract my 3 from everything. Divide by 2 from everything. And I get negative 4 is less than equal to x is less than equal to 1. And that's good. All done. So, if it's absolute value with a less than or less than equal to, it's a conjunction and. I'm going to sandwich it. Well, let's do 2 more examples where I mix up the 2. So negative 2. That'll be negative. That'll be positive. Negative times positive is negative. Yes.
So it's in between?
It's in between because it says it's less than, so it's in between those. So
you put, which one did you put? Like in
negative 7 is less than x is less than negative 3/2. Done.
What do you, that's all?
Yeah, it's between those two.
So you just put the x in the middle?
Okay. All right. Let's say I have 2 times the absolute value of x plus 1 is less than 8. And let's say I have absolute value of x plus 3 minus 1 is greater than equal to 4. So this case, sandwich or not? Sandwich, okay? Because it's less than. So I get my absolute value alone by first dividing by 2. Now I need to split it, right? But before I split it, I quickly use my number line and I think. which case do I have? All the absolute values that are less than 4. That would be this case. So I have negative 4 is less than x plus 1 is less than 4. Between those. Subtract my 1. Negative 5 is less than x is less than 3. Done. Here, I'm going to add the 1. Plus 1, get it alone first. So for the other one, do I have a sandwich or do I not?
Use or.
It's going to be or. Draw my number line, just a sketch, so I know what's going on. I want absolute values that are bigger than 5. So that's, or equal to. So that's going to be this case. Use this graph to help you. So this one, see, I put this thing that was an absolute value in between two things because according to my graph, it's in between two things. In here, it's two different things. So x plus 3, see which direction that's going? Less than or equal to negative 5. And x plus 3 greater than equal to 5 because of my graph. And then I solve both of those. Negative 8. 2. And it's an or, because it's going two different ways. Done. And we are happy. Or we're confused. Or we have a black eye, depending upon what has happened. And it's a potato. It's Mr. Potato Man.
So wait, explain why you use that sign again? The info there, the negative option.
Why it's this way?
Yeah.
Do you understand why it's this graph?
Yes.
Because I'm looking for the absolute value of numbers. See, absolute value. The absolute value, all the numbers whose absolute value is bigger
Yes.
than 5. The absolute value of negative 10 is 10. Is that bigger than 5? Yes. So I have all these numbers all the way up going to negative 5. And then none of these are going to work because their absolute values are less than 5. The absolute value of 5, close. Absolute value of 10, bigger than 5. So I use this graph. Well, what's this look like? This is pointed, see, pointed the same way. Less than, bigger than.
In other words, like in the negative numbers, the higher you go, the less it is.
I don't understand what you mean by that. I'm just saying absolute value. Negative 10, that's 10. Does that work in this situation? Yes, that works. Therefore, all of these going infinitely small, because that I'm getting further from 0, their distance from 0 keeps getting bigger.
That's what I was meaning. Not absolute value, but I mean just negative numbers in general. The bigger you go, like the bigger the number is, the smaller it's getting because it's getting through.
Right, but its distance from 0 is getting larger. Okay, so we'll call that. That's good.